各位老師、同學、家長，大家好，歡迎參加由香港中文大學入學及學生資助處主辦嘅 One Hour SHK 網上活動系列。我係今日活動主持人 Cleo， 好高興同大家見面。今日嘅體驗課堂係由中大教育學院教育學士數學及數學教育課程提供嘅，主題係高中數學大探究。為咗唔影響活動嘅進行，各位嘅咪會被預設為靜音。如果大家有問題嘅話咧，可以利用熒幕下方 Q&A 問答嘅功能去輸入問題，我哋嘅嘉賓會盡量回答大家嘅提問。今日我哋好高興邀請到中大教育學院助理教授吳靄藍教授、高級講師陳業祥博士及教育學士數學及數學教育課程4年級同學 Elaine 同埋 Alvin 擔任是次嘅講者。好啦，事不宜遲，我而家首先將個時間交俾陳博士啊，唔該 Dr. Chan。
各位歡迎各位同學同埋老師家長就參加我哋嘅呢一節嘅 One Hour SUHK 啦。咁嗱，呢一節咧就係由教育學士數學及數學教育課程雙主修課程嘅嚟主辦嘅。咁我係呢個課程嘅課程主任陳業祥博士啦。咁嗱，教育學士數學及數學教育課程咧係一個5年制嘅專為培訓香港中學數學老師嘅課程。咁同學咧，除咗會修讀由數學系負責嘅科目，亦都會修讀教育學院負責嘅教育研究同埋數學教育科目。咁畢業之後咧，你喺香港係會成為一個認可資格嘅中學數學老師。咁如果同學咧想了解多啲我哋嘅課程咧，可以望一望我哋右手邊嘅 QR code，咁就有我哋課程嘅網頁嘅。咁喺我哋嘅課程網頁裏邊咧，其實就有好清楚我哋嘅課程目標啊、學習成果啊，諸如此類一啲好重要嘅資料嘅，亦都咧你喺上邊我哋嘅課程網頁裏邊，亦都有學生嘅一啲嘅生活嘅情況啊，佢哋嘅學習體驗，包括係課程裏邊同埋課程以外嘅一啲實驗，仲有一啲嘅獎項啊嘅記錄，咁所以好多豐富嘅內容你可以去參考。咁嗱 One Hour SUHK 咧係大學課堂體驗嘅活動嚟嘅。咁今日嘅環節咧就好特別，咁因為咧就主要唔係由我哋大學老師負責嘅，咁就係頭先司儀都講係由我哋嘅4年級2位嘅同學負責。咁個原因咧就係喺我哋嘅數學教育科目裏邊咧，通常就會有一啲叫做微格教學，英文叫 micro teaching 嘅環節。咁就係咧由我哋嘅同學 undergrad 嘅同學咧就輪流就扮中學老師，咁其他同學咪扮學生咯。咁然後咧，我哋去試教，咁就喺佢真正入學校實習之前咧，就可以有一個喺教學實習嘅技巧嘅練習同埋實踐，亦都咧係可以咁樣係得到同學同埋老師俾嘅意見。咁所以今日嘅環節咧，其實個目的就係讓大家參與者咧去體驗究竟我哋嘅 micro teaching 嘅環節係點樣進行。咁當然今日咧係有個同以前唔同。咁以前我哋喺課堂裏邊嗰啲嘅學生其實就係 undergrad 學生扮嘅，咁而家今日我哋係好多謝大家參與啦，有真實嘅學生就係你哋每一位啦，咁就參加。咁嗱喺2位同學試教之後咧，我哋亦都會有我哋嘅副課程主任，亦都係任教其中呢個嘅數學法教學技巧與 STEM 活動嘅吳靄藍教授咧，為我哋做一啲嘅總結。咁嗱呢一個科目咧，其實係好與時並進嘅教學科技與 STEM 活動。咁顧名思義咧，其實我哋係特別着重點樣去利用科技 STEM 嚟到促進數學學習嘅成效嘅。咁因此咧，你哋今日咧一間你會見到我哋2位同學咧，係佢會係用科技嚟到去促進咗一個嘅教與學同埋個互動嘅。咁都唔阻大家時間啦。咁我哋咧首先咧會由Elaine 同學，咁佢會任教 Linear Programming 線性規劃。咁跟住咧就由另一位同學都係4年班嘅同學 Alvin Chan 咧，咁就會任教 Trapezium。咁我先咧將以下嘅時間咧就交俾Elaine 同學啊。
Hello， 大家好，我係Elaine。咁我今日會教嘅 topic 咧就係 Linear Programming 啦。咁首先咧就同大家 share 一下個 program， 我哋做下一啲重溫先。咁喺講線性規劃之前啦，想同大家重溫一下一啲不等式嘅內容啦。咁首先我哋記翻起咧，不等式咧就係有4個符號嘅，咁分別咧就係大個啦、細個啦、 大過等於同埋細過等於嘅。咁跟住落嚟咧，我哋就睇下點樣用一個 graphical solution 去睇佢哋嘅式咯。咁望下以下呢4幅圖啦，咁全部都係講緊 x 加2 y 同2之間嘅關係啦。咁我哋點樣釐清佢哋之間嘅關係咧？首先我哋就睇下上下兩幅圖嘅分別啦。咁就係分別係實線同虛線嘅分別。咁就係講緊啲乜嘢咧？就係講緊係嗰條線嘅嗰一點究竟代唔代表個 solution 啦。咁如果佢係一條實線嘅話，即係等於係包括埋喺個 solution 入面嘅。咁所以咧喺呢兩條式入面咧，我哋就會加翻個等號俾佢哋先嘅。係啦。好，咁跟住我哋睇下點樣分佢係大個定細個咯喎。咁我哋可以睇翻 solution 啦，我哋可以 set up 一個測試點啦。例如我哋可以喺00呢一個位去做一個測試點啦。我哋睇下00喺唔喺佢嘅解決佢嘅 solution 入面啦。咁我哋可以 set x 等於0啦，然後加2乘以0。咁我哋知道呢個係等於0啦，而0係細過2嘅。咁所以我哋就知道0係唔喺佢嘅 solution 入面啦。咁所以咧，我哋就知道呢個係大過等於。咁相反而言啦，呢個00係喺入面嘅時候咧，我哋就可以將佢作為細過等於。咁而頭先講過啦，上面幅圖同下面幅圖唯一嘅分別咧，就係有等號同冇等號嘅分別啦。咁所以呢個就係大個同細個啦。好，跟住我哋睇下點樣去 solve 一啲 graphical solution 喎。一個 system of linear inequalities 啦。咁我哋睇翻呢度有3條式，咁我哋就可以每一條式都去 set 去揾翻佢個 solution area 啦。咁例如呢個，即係我哋依然可以當00係一個 testing point 啦，就係0加0啦。我哋知道等於0係細過等於5嘅。咁所以咧睇翻綠色呢一條線咧，我哋就可以望住佢個方向咁樣畫一畫。然後再望下橙色呢一條線啦 ，y 大過等於-2啦。咁如果0嘅話，我哋知道0的確係大過等於-2嘅。咁可以咧，就係呢個方向啦。最後我哋睇埋藍色呢一條咧，7x 減 y，70 減0。係等於0啦，0係細過等於2嘅，咁所以咧0就唔應該喺藍色呢條線嘅 solution啦，所以我哋係唔會咁樣畫啦，咁就喺另一個方向。於是我哋總結咧就可以睇得出呢3條線嘅 solution 咧就會喺呢一個 area 入面。咁我哋咧就會叫做呢個 area 咧就叫做 feasible region， 亦即係可行解區域。咁大家喺呢方面要留意一個點咧，就係00只係一個任意嘅點嚟嘅。我哋無論用，只要喺幅圖裏面任何一個點都可以成為佢嘅測試點。例如我哋可以 set up-2作為每一條式嘅測試位都 OK 嘅，只要佢嘅唯一要求就係唔喺嗰條線入面就 OK 噶啦。好，咁首先而家為咗測試下大家聽唔聽得明以上講嘅嘢咧，大家而家可以 log in 一個 Desmos， 我做咗一個少少嘅測試俾大家，係啦，咁你哋而家就可以入呢一條 link， join 呢一個 code。好，大家如果 join 咗呢條曲咧，就可以入去。好，首先我哋望下第一條問題先啦，大家可以睇下嗰個究竟。 係啦，俾多10秒時間大家思考下呢個問題啊。5、4、3、2、1，好，我哋嚟睇下大家答案嘅結果先。好，我哋見到有90幾位同學都係答 true， 然後有10位同學係答 false 嘅。咁咧呢一題嘅正確答案咧就係 true 啦。咁我可以望一望啦。我哋可以睇翻，如果我哋將00作為一個測試點嘅話，我哋就可以睇到0加3乘0加0係等於0啦。咁0係細過20嘅，咁所以00會係呢一條不等式嘅 solution 之一啦。咁所以呢一題咧就係 true 嘅。好，跟住我哋試下一題咯。好。好，俾多10秒時間大家作答啊！10、9、8、7、6、5、4、3、2、1。好，好，見到我哋呢一題嘅答案係相對比較懸殊啦，有30幾位同學係答咗 true 嘅，然後咧有86位同學係答 false 嘅。咁我哋諗下，可能大家會見到呢一個點上面，大家咧如果攞00去作為一個測試點嘅話咧，係冇辦法做到個效果，因為你發覺0係會等於0嘅。咁如00係喺呢一條線上面喎，所以我哋唔可以將00作為一個測試點。呢個時候咧，我哋就可以另外再設立多一條式啦。咁可能係22咁樣啦。然後咧，佢就可以，如果係22嘅話，咁5乘2咧就等於10啦。然後減2乘2咧等於8啦。我哋就知道10減8等於2咧，2係大過0。咁所以咧呢一題咧，白色嗰啲位先係佢嘅 solution， 而紫色 highlight 咗嗰啲位唔係佢嘅 solution 啦。咁所以呢題嘅答案就會係 false 嘅。咁可能好多人就未必留意到00呢一個位啦，係啦，呢個需要注意嘅。好，最後俾大家試下一個 system of linear inequalities。好，我諗聰明嘅大家應該而家可以得出一個結果啦。我哋嚟睇下大家嘅成果先。咁咧係啦，呢題比起上一題又有進步喎。大部分人都係答 true， 然後只有18個同學係答 false 嘅。咁大家都睇得出。如果根據翻頭先嘅邏輯啦，我哋就可以知道呢一題嘅答案就係呢一個三角形就係佢嗰個可行解區域啦。咁好啦，咁同大家做咗一個少少嘅測試啦，發覺大家都好聰明啊，係明白嘅。咁我哋而家做一個，我諗大家好疑惑，究竟 linear programming 喺日常生活之中有咩作用咧？點解我哋成日都要學埋啲好似好抽象嘅嘢，好似冇乜作用咁樣啦？咁 或者我舉一個比較實際少少嘅生活例子俾大家啦。即係我知道而家喺疫情嘅時間，其實大家都冇乜機會去開 party 啊或者慶祝啦。咁可能期望大家疫情完結咗之後咧，我哋就會有啲 gathering 啊嗰樣嘢啦。咁好多時人生會有好多限制噶嘛。咁我哋班嘅同學咧，假設而家即係好希望疫情完啦，咁而家疫情完結咗啦，我哋要開 party 啦，咁要飲嘢噶嘛，係咪？咁咧，咁而家咧就投票俾大家決定可以飲啲乜嘢喺個 party 上面，係啦。要開 party，睇下大家中意飲啲乜嘢。咁我哋下次咧開班會 party 嘅時候咧，就可以揀最高嗰兩樣嘢去飲啦。好，俾多少少時間大家。好，我諗大家都答晒啦。咁我哋嚟睇下個結果咯。好，應該咁呢個。好，好，個結果我哋睇到啦，有嗱而家 fix 咗啦，大家唔好再撳啦吓。好，咁而家咧我哋就見到有30位同學咧就想飲可樂啦，然後有34位同學飲朱古力奶啦，咁其他咧都係少過呢兩個數字嘅，咁所以咧我哋班咧就決定淨係買可樂同埋朱古力奶啦。咦，咁你話問呢個問題做乜嘢咧？好啦，跟住就嚟咯，問題就嚟啦。嗱，以下呢個咧就係個價格清單啦。咁我哋記住咯，可樂咧就係賣7蚊嘅，而朱古力奶咧就係賣6蚊嘅。好，咁我哋班會開 party，梗係我哋自己俾錢噶啦，係咪先？咁所以咧就會有好多唔同嘅 constraint，我哋係需要考慮我哋嘅開支各樣問題噶嘛，係咪？嗱，我希望大家首先記住而家可樂賣幾多錢，同埋朱古力奶幾多錢啦。好，跟住我哋嚟睇下我哋有咩限制咯。我哋班就有50位同學啦。咁我哋首先第一件事，當然要確保我哋每位學生都至起碼有一盒嘢飲先啦，係咪先？喺 party 上面冇嘢飲就太過分，係咪先？好，咁而第二樣嘢啦，咁兩種飲品都係要平均嘅。咁嗱，我哋望下咯，喺呢個 constraint 入面啦，我哋飲品 X 即係最高數量，即係朱古力奶嘅數量啦，係不能夠少於飲品 Y， 即係可樂嘅數量嘅2/3。嗱，咁希望大家兩款嘢飲都有得飲啊嘛，係咪先？然後咧，第三件事咧就係超級市場 constraint。我哋而家去買嘢嗰間超級市場咧，佢每一款飲品咧都最多只能夠購買60盒。咁所以咧，喺呢種情況底下，我哋點樣用最低嘅成本去購買一啲我哋所需要想要飲嘅可樂同朱古力奶咧？係啦，咁不如我哋逐條諗下先啦。喺第一條 constraint 之下，其實就係等於啲乜嘢咧？第一條 constraint， 如果我哋叻咗 X 係朱古力奶而 Y 係可樂嘅時候，咁如果每位學生至少有一盒飲品嘅時候，我哋嗰條不等式會係乜嘢咧？係啦。 好，我哋望下少少大家嘅反應咯。x 大過等於1 y 大過等於1係講緊每一盒嘅嘢飲需要大過等於1，但係你冇辦法確保每一位學生都至少有一盒嘢飲。咁我見到咧，大部分嘅同學都答啱嘅，冇錯啦，就係 x 加 y 係大過等於50，係啦，因為我哋班係有50個人嘅。好，跟住我哋睇下第2條 constraint 又可以點樣去設立咧？好，俾多少少時間大家思考啊。好，我哋嚟睇下 summary 咯。好，發現好多同學都係答 x 大過等於2/3y。咁其實咧，第一個表達方式同第二個表達方式咧，其實係一樣，因為我將 y 無論擺喺上面定係擺喺側邊，其實佢個結果係唔會有分別啦。咁然後我哋睇下下面呢一條咧，都係一樣嘅，係啦。但係呢個咧就可能調轉咗個分子分母啦。我哋要留意翻係數量嘅2/3啦，係啦。好，咁大部分同學都係答啱嘅。好，然後仲有一條約束條。每款飲品最多只能夠購買60盒，咁可能係唔止一條式嘅喎，咁我哋可以諗下。好，我諗大家都答得差唔多啦，咁我哋嚟睇下結果咯。咁就可以睇得出咧，大部分同學都答啱啦，就係 x 細過等於60，y 細過等於60啦，係啦。但係點解我哋唔可以用 x 加 y 細過等於120咧？因為 x 同 y 係講緊兩款唔同嘅飲品啊嘛。咁如果我係 x 30盒 y 100 y 90盒，我都依然係可以做到呢一個條件噶嘛。咁但係我 y 係冇可能買到90盒噶嘛，所以我哋唔可以用咁樣嘅表達方式去表達呢一個嘅約束條件啦。好，咁大家諗下有冇其他 constraint 咯？我見到有同學係填0同 x 同60之間啦 ，y 都係0同 y 同60之間啦。咁佢就好醒目嘅，因為知道咧飲品咧係冇可能係一個負數啦，係啦。咁當然啦，每盒飲品都係一盒一盒咁賣噶嘛，所以佢一定係一個整數嚟嘅，係啦。咁以上就我哋 constraint 啦，跟住就俾啲時間大家試下去畫咗嗰個幅圖出嚟，即係好似第4幅圖咁樣去畫，係啦。咁呢個時候咧就可以俾大家喺其他版度做一個，係啦。 好，咁如果大家唔記得我哋之前寫嗰啲咩 constraint 嘅話，你哋可以自己撳翻去之前嘅 screen 嘅，係應該可以做到呢件事嘅。好，俾多少少時間大家試下畫啊！大家都有相對嘅概念嘅，見到係你可以撳入去，然之後咧喺上面撳呢啲繪圖嘅符號咧，你就可以喺呢一幅圖上面進行一啲繪畫嘅工作，係啦，你哋可以自己試下。好，我都喺 Zoom 嘅 chat room 同大家整合咗少少我哋所有嘅約束條件嘅，係啦。咁我見到有啲同學都完成得相當之好啦，或者我哋係啦，或者時間差唔多，我哋揾一個嚟睇下。好，見到呢位同學咧係畫得相當之好嘅。我哋就見到唔同嘅 constraint 都喺晒度啦。咁如果畫好少少咧，我哋其實應該係可以喺呢啲色上面去加翻佢嗰條色究竟係代表啲乜嘢。例如呢一條線係講緊 y 等於60呢一條線啦，係啦。咁咧我哋就如果可以 mark 翻每一條線係咩色就會更加之好啦，係啦。同埋我哋 mark 嘅時候咧就用翻等號，就唔需要用到大過細過等於嗰啲不等式嘅，係啦。咁呢度做個少少嘅溫馨提示啦。可能係因為我頭先嘅示範冇做好，係啦。咁係啦，希望大家記住啦。咁呢個 solution 係啱嘅。好，咁究竟我哋揾呢啲揾咗個 feasible region 出嚟有咩用咧？好，由於時間關係啦，就幫大家填好晒呢個表啦。我哋就知道嗰個 area 咧就會係呢一個1、2、3、4、5呢個5邊形嘅。咁我頭先叫大家記住我哋要買嘅嘢飲係幾多嘛？你記唔記得我哋一開始嘅問題係乜嘢啊？其實係講緊我哋想喺最低嘅成本之下，然後可以符合到所有約束條件，然後我哋可以買到嘅可樂同朱古力奶嘅數量分別係幾多？係咪？咁我哋記住咯 ，X 係朱古力奶啊嘛，咁朱古力奶嘅價錢咧就係6蚊啦，而可樂嘅價錢咧就係7蚊啦。咁如果我哋要計我哋買呢兩款飲品嘅成本咧，其實就係講緊6x加7y。咁而我哋頭先咧就喺呢度揾到一個，我哋就揾到我哋所需要喺可行嘅情況底下，我哋可以解決到嘅成本啊嘛。咁所以咧，我哋就而家只係需要喺呢一個 area 入面咧，去揾到佢嘅最低成本就 OK 啦。咁呢個時候我哋可以點做咧？咁喺 response 或者我做個示範啦。嗱，加翻條色入去啦。咁 C 其實就係我哋嘅 cost 啦。我哋可能一開始 set 佢做0先啦。然後我哋個成本係講緊6 x 加 7y 等於 c， 係啦，等於 c 呢條式啦。咁我哋咧就要將佢拉嚟拉去。咁大家可以試下自己輸入呢一條式，然後嘗試拉一拉呢條線，去睇一睇佢幾時到達佢嘅最低點啦，同埋最高點咁樣，係啦。係啦，或者大家自己可以研究下。咁由於時間嘅關係咧，咁我就俾個答案大家啦，就應該係呢一點啦。咁所以咧，我哋應該用300蚊咧就可以買到最低我哋用300蚊就可以買到我哋所需要嘅飲品啦。而分別就係呢一點，係啦。其實咧就係買晒50盒。係啦。好，咁而家同大家做一個少少嘅總結啦。咁至於幾時我哋拉向左手邊係 minimum maximum 咧，咁呢啲咧我哋就留翻下一堂再講，係啦。咁我哋而家做一個少少嘅總結啦。我哋今日學咗啲乜嘢啦？咁其實咧就係學咗少少關於不等式嘅應用啦。係啦，有少少不等式嘅應用啦，同埋有少少佢喺日常生活當中嘅應用啦。咁希望大家可以善用呢啲諗法啦。咁可能日常生活當中都會遇到好多唔同嘅限制，咁我哋可以利用我哋所學到嘅知識去解決生活當中嘅困難。係啦，多謝大家。咁我時間交翻俾大會。
Welcome to the second lesson of today. Before our lesson begins, please type in the link above itemboot.com/teacheropen/live, or maybe scan the QR code in this corner. We will be using this itemboot.com throughout the entire lesson. And so after I have answered this question, let's just see how the statistics goes. So it seems that there's a major trend that 43 of you answered the same question. So in case you still haven't figured out what the question is asking you, what best describe your relationship with the trapezoidal rule? As of course, our second lesson is talking about the trapezoidal rule. Let's wait for a few more seconds and see if there are any Q&A live. answer. Oh, by the way, if you have some questions that you want to ask in the Q&A session, in the Q&A box, you can type your answers. And if we see it, then we will answer as soon as possible. So there are 56, 55. 55 of you chose the same answer. So let's just review the statistics, shall we? So it seems that there are 55 of you haven't heard about what trapezoidal rule is. So I assume that you guys are from and are studying M2, right? But no worries. We will be talking about trapezoidal rule from definition to its application, and of course some of its characteristics. So let's begin our second lesson, shall we? So, but before we talk about trapezoidal rule, of course we have to talk about definite integrals. So definite integrals is defined to be area bounded by y equals to fx and the x-axis. So basically the red shade area is the area. So it can be calculated by using the definite integral. So integrate from a to b f of x with respect to x. But unfortunately, there are just some integrals that are very complicated for us. So we need to use a little bit more advanced tricks to do so. And there are just some integrals that are not integrable, at least within the scope of the HKDSE syllabus. So we need a new method to calculate these definite integrals, right? So how are we going to do it? Well, we need to think in terms of the definition again. But unfortunately, by definition, of course, I'm not talking about this whole chunk of thing, because obviously you don't want to look at it. Well, we are talking about the geometric representation. And for simplicity, we're not going to compute the definite integral directly, but we are going to estimate the area instead of computing it. So here's another question. If you will, please refer to itempool.com. Do you think rectangle is a really good way of estimating on the area under the curve? So you've seen there are some spaces left out here. So do you think using rectangles would be a good idea? Let's take a look at our statistics. So again, please just answer in your mobile phone, or if you're using your computer to access itempool.com, then please use your computer to answer it. By the way, let me take a look at the Q&A session. I'm curious what those 24 answers are from. So let's just give it a sec. So 65 of you, 68. Well, let's just review our answers, shall we? It seems that 68 of you think it's not a good idea to use rectangle to estimate the area under the curve, but 34 of you think it's a good idea. No worries. Let's take a look, because there are some spaces left out, right? Because these spaces are left out, so actually the area in estimating the area under the curve could be significantly large. Well, a Q&A asks, is good enough if we take limit? So of course, if we are using limit to estimate, then of course it's a good idea. But then the point is we are going to estimate instead of computing it, because limit will be served as a method of computation instead of estimation. So unfortunately, we are going to use a finite geometric objects. So we're not going to use limit, but we are going to use finite number of shapes. But then again, if we are going to use a finite number of shapes, then there are actually huge spaces left out. So instead of rectangles, mathematicians deduce another method, that is to use trapeziums to estimate the area. And as you can see, if we use trapezium to estimate, then actually the spaces are covered in our estimation. And so we are going to deduce the formula for trapezoidal rule using this diagram. But then again, we are going to introduce some terminologies first. So since this line segment is B minus A, and we are going to use 6 trapezium, which we label 1, 2, 3, 4, 5, 6 to label them. So each of this length is defined by B minus A divided by 6, or maybe we use delta X to represent it. And so this point is A f of A, and this point is B f of B. So as mentioned just now, we are going to estimate the area under the curve. So we have to calculate each of the area of these 6 trapeziums one by one. Don't worry, I will guide you through. But before we begin, let's take a look at the formula for computing the area of trapezium. So oops. Oh, no worries. Assume I can put.com first. Oh, page number. Oh, yeah. Here. So which of the following represents the formula for calculating the area of trapezium? Okay, should be simple enough, right? So, did someone? Let's see the statistics of it. So the majority of you chose the right answer, which is 1/2 times the sum of lower base and upper base and times height. So unfortunately, if you choose A, then well, no worries. Maybe consider it as a warm-up just to help you memorize the formula for trapezium. So let's get back to our iPad screen. So we know that the area is actually calculated by 1/2 of lower base plus upper base, and then times the height. So this is the formula for calculating the area of a trapezium. So let's just calculate our estimation one by one. So for trapezium 1, we know that the lower base is actually given by f of A plus delta X, and the upper base is given by f of A. And of course, the height is given by delta X. So the area for 1 is actually equal to 1/2 times f of A plus f of A plus delta X times delta X. So this is the area for 1, or if you will, I will rearrange some of the terms for future users. So I will put the delta X in front of the sum of upper and lower base. So this is the area for trapezium number 1. Now let's get on with trapezium number 2. Notice that trapezium number 2 for this point is A plus delta X0. And this one is A plus 2 delta X0 because the length is actually given by delta X, right? So we know that the lower base is f of A plus delta X, and the upper base is given by f of A plus 2 delta X. And so plug in the formula again, then we will get the area for trapezium 2 will be given by 1/2 times delta X times f of A plus delta X plus f of A plus 2 delta X. So the procedure goes on, and we will skip trapezium 3, 4, 5, 6. In summary, to the area is actually given by this whole chunk of things. But no worries. It sounds complicated, I know, but actually, if we organize the terms a little bit, then it's gonna look much better. So let's take a look at here. We see that trapezium 1 take this as the lower base, right? And for trapezium 2, this is taken as the upper base. So for trapezium 1 and 2, they share the same line segment. They share the same line segment, and hence we can see f of a delta x in here and in here. And then for the second, for trapezium 2 and trapezium 3, they also share the same line segment, and it's linked with f of a plus 2 delta x. And so on and so forth. We see trapezium 3 and 4, trapezium 4 and 5, and trapezium 5 and 6. They all share the same line. So in fact, we can actually combine these two, and then we get the following formula. So taking a 1/2 delta x, because they're the common factors, right? And then we got f of a plus 2 times f of a plus delta x plus f of a plus 2 delta x plus f of a plus 3 delta x plus f of a plus 4 delta x plus f of a plus 5 delta x. And finally, we have to add the last term as well, which is f of b. So we have the f of b here. So notice that the 2 is only applicable for f of a plus delta x, a plus 2 delta x, 3 delta x, 4 delta x, and 5 delta x only. So this is the formula for estimating the area under the curve using 6 trapezium. How about n trapeziums? Or we usually use n subintervals to represent n trapezium. Well, actually, the idea is the same. But to save time, we're going to give you the formula. So the formula for estimating the area under the curve from A to B is actually given by 1/2 times delta x times f of a plus 2 times f of a plus delta x up to n minus 1, and then plus f of b. So where delta x is actually given by b minus a divided by n. So this time, because we're using n subintervals, right? Since we're using n subintervals, where delta x is given by b minus a divided by n instead of b minus a divided by 6. So let's take a look at an example, okay? So consider f of x is equal to this one. 1 over the square root of x plus 2. So the question asks us to integrate f of x from 1 to 5 using 4 subintervals. So we first have to calculate the delta x. So the delta x is actually given by b minus a, which is 5 minus 1, divided by n, and n in this case is 4. So this one is 1. And therefore, the area under the curve using trapezoidal rule to estimate is actually given by 1/2 times delta x, which is 1, times f of 1 plus 2 times f of 1 plus 1, because a plus delta x, right? But 1 plus 1 we know obviously is 2, plus f of 3 plus f of 4, and then plus f of 5. So this gives us 1.8331. I see a Q&A answer says, as I am a M2 student, can trapezoidal rule be used in M2 DSE paper? Well, if the question asks you to estimate the area under the curve using, yeah, or maybe I answer. Okay, so a question asks, as I'm a M2 student, may I ask, can trapezoidal rule be used in M2 DSE paper? Any mark will be deducted. Well, if the question is asking you to estimate the area under the curve using trapezoidal rule, then of course you have to use the trapezoidal rule. But unfortunately, in the M2 DSE syllabus, trapezoidal rule is not included. So basically, the DSE paper won't ask you to use trapezoidal rule to estimate an integral. And if you use it, I believe marks may be deducted. So use it well. But by the way, thank you for asking. So now let's get back to our iPad. So integrate one f of x from 1 to 5 using 4 subintervals is actually given by is actually equal to 1.8331. And in terms of the graph, the green line is y equals f of x, which is equal to 1 over square root of x plus 2, right? And these blue trapezium are the estimated area. So I hope you guys learn a lot. And let's go on to talking about some of the characteristics of trapezium. But before we do that, I want to ask, what is the value of integrating from 0 to 1 x squared dx? So I will open up in pool and let's see if you guys can answer this question. In the meantime, okay, so let's see if you guys remember how to calculate the definite integral. Okay, let's review our answers. So the correct answer is actually equal to 1/3. Don't worry if you answer this wrongly. It's just a practice, and of course, marks won't be deducted because this is just an online class for you to learn. So the area. So actually, we know that this definite integral is equal to 1/3. But what if we use trapezoidal rule to estimate? So let's go on here. So we see that this is a y equal to x squared curve, and our integral is given by this one, and it says this definite integral is equal to 0.3333, which is actually just the same as 1/3. But we also see something is written below. So it says area estimate using 2 subintervals is equal to 0.375. So because we're just using 2 subintervals, right? So obviously there will be some error. But what if we use this more subinterval instead of just using 2 subintervals? So let's say if n is equal to 7, then the area is actually given by 0.3367. How about if we use 12? It still equals to 0.3345. So we see that regardless whatever value of n that we take, our estimate using the trapezoidal rule would be greater than the actual value. And why is that? Why is that? Well, actually, the graph, if you remember, the graph of y equals to x squared is a concave upward graph, right? So if we consider all concave upward curve, then we actually see that no matter how many subintervals we are going to use, the trapezium will actually take a little bit more than it needs. So in general, we know that the estimated area is actually greater than the actual area. So if it is a concave upward curve, then the estimated area would definitely be greater than the actual area. But how about this one? Do you think this one would be the estimated area using trapezium, using the trapezoidal rule would be greater than the actual value? Let's take a look at our answers. Oh, by the way, this one we call the estimate to be an overestimate. So let's take a look at the itempool.com again and see if we use the trapezoidal rule to estimate, it's going to give us an underestimate or an overestimate. So let's take a look. It seems that the one of the answers has take is the majority instead of half. No worries. What if the function is not? Okay, let's take a look at the statistics. So, well, if we are going to use trapezoidal rule to estimate this definite integral, then it would give us an underestimate. For those who answer overestimate, no worries. I will explain why. In fact, if we take a look at this one, at the graph, so the green line represents the curve for y equals to negative x squared plus 5. And we see that if b is equal to 1, then the definite integral would be 4.6667. And the area estimate using the trapezoidal rule would actually be a little bit less, which is 4.66. So what if we use more trapeziums? It's still going to be less than 4.6667. And the reason is because for a concave downward curve, as we can see that this function is a concave downward curve. For a concave downward curve, no matter how many trapezium we use, there's still going to be spaces that are being left out. So obviously, we know that the actual area is going to be greater than the estimated area. And we call this as estimated area an underestimate of the definite integral. I hope you guys know. So for the time being, let's do a quick summary. So the trapezoidal rule with n subinterval is actually given by this formula. So all you have to memorize is we're going to use half times delta x times f of a plus 2 times f of a plus delta x, and so on, up to a plus a minus 1 delta x. And then, of course, don't forget the f of b. And notice that the delta x is actually given by b minus a divided by n. And if it is a concave upward curve, now, so for those of you, if you study well in M1 and M2, you will notice that a concave upward curve would imply f prime prime x is greater than 0. So for a concave upward curve, it would give us an overestimate, or the trapezoidal rule has overestimated the actual area. And similarly, if it's a concave downward curve, which also implies f of f prime prime x is less than 0, then the trapezoidal rule will give us an underestimate, or it underestimated the area under the curve. So are there any questions? Okay, are we able to access the recording for further reference? I will leave that answer to, I will leave someone else to answer this question. So, what if the intersection with the x-axis lies between two partition points? Or do we arbitrarily choose the intersection to be a partition point to avoid this problem? Well, so this, thank you, Mark. So you have asked a very good question. So it says, if I understand it correctly, it says, so if I have a function like something like this, and I want to estimate the area. So let's call this, and I want to estimate this. So would this gives us a underestimate or overestimate? So in general, if there's a concave upward curve, then it will give us an overestimate. And if it's a concave downward curve, then it will give us an underestimate. So so basically this is the idea. And don't worry, the DSE won't cover this kind of problem because it actually involves a little bit more about the advanced idea of trapezoidal rule. Is there any method to estimate the area between the curve and y-axis? Well, Fong Yatong asked, is there any method to estimate the area between the curve and the y-axis? Well, that is a tricky part of the question, but it actually involves something like a function like x equals to f of y. So I will leave the answer to you. I'll leave it to you to answer it by yourself. But you can consider something like this. And okay, it's 7:02. Now I will. I hope you guys learn a lot. Now I will pass the time to Professor Ng. So thanks for attending.
Thank you very much， 多謝晒 Alvin 同埋 Elaine 今日準備嘅好有趣嘅數學課堂俾我哋。亦都希望咁多位咧係喺今日咧可以透過呢一個活動去認識我哋中大BMED 簡稱數教呢個課程嘅一啲嘅課堂嘅生活，同埋亦都好重要咧，就係去學下啲而家你哋學緊嘅一啲嘅數學、中學數學嘅一啲嘅課題咁樣樣。咁最後咧我想喺呢一度再邀請大家去繼續去參與我哋嚟緊嘅一啲嘅活動同埋課堂咁樣嘅。我喺個 chat 度咧 send 咗俾大家一個 link， 咁呢一個咧係一個 Google Form 嚟嘅。如果你入去咧，你就會可以去enter 你嘅一啲嘅 information 啦，咁就我哋會有嚟緊由3月開始咧，都會每個月咧都會準備一堂課係去咁樣去教俾大家睇咁樣樣，同埋咧嚟緊係 DSE 啦，咁我哋嘅學生咧都好有心，佢哋除咗去準備佢哋嘅專業之外咧，亦都好想去服務翻中學生咁樣樣，咁佢哋亦都準備咗一啲嘅課堂去同大家一齊去準備 DSE 咁樣樣，咁所以如果大家去入咗呢個 Google Form 擺咗你嘅 information 之後，我哋就會 send 啲 email 同埋一啲嘅資料俾大家，咁希望我哋到時又可以再見咁樣。好咁我就交翻時間俾入學組嘅同事，同埋大家記住入呢個 information， 咁我哋就會遲啲再見咁樣。唔該晒。
多謝吳教授、陳博士、Elaine 同埋 Alvin。相信各位聽完嘉賓嘅演講之後咧，對數學教育呢個課程都有多啲了解。如果大家對呢個課程有興趣嘅話咧，可以歡迎去我哋嘅網上聊天室。今日我哋好高興邀請到數學教育即係 BMED 呢個課程嘅學生大使咧，喺而家直到晚上7點半喺網上嘅聊天室去回答你哋嘅問題，同埋同你分享佢嘅讀書生活。網上聊天室嘅網址咧，你而家可以喺 chat box 嗰度揾到。除此之外，如果大家對剛才 Elaine 同埋 Alvin 分享嘅課題覺得有興趣或者有疑問嘅話咧，都可以掃描而家熒幕左下方呢個 QR code 進入課程嘅 Instagram、IG 專頁去留低你哋嘅一啲問題嘅，課程代表會盡快回覆大家。 除咗喺大家登記嘅時候，你已經拎咗一個 WhatsApp 嘅貼圖包之外呢，我哋將會喺活動完結咗之後，抽出5名嘅參加者，送出一份精美嘅小禮物嘅。得獎者會收到電郵通知，大家記得留意啦。今日嘅體驗課堂到此為止，再一次多謝各位嘅參與。我哋嚟緊喺每個星期5都會提供各個學院嘅體驗課堂，歡迎大家報名參加。期望喺嚟緊嘅活動再見到大家，拜拜。